All right, I'm going to go over the Unit 6 work for, sorry, my brain is fried. It's Unit 6 circles. What are we talking about here? I need to go over the 429 assignment. So you'll see this here, areas of sectors and arc length in circles. It's only 6 questions. So we're going to go over it together. That way you can get this submitted and get a 100. Okay, let's look at question number 1. Question number 1, what is the area of the circle below? Leave your answer in terms of pi. And, oh, I terribly worded that question. It should be the area of the sector of the circle below, so the shaded area. I hope you don't mind, but I'm going to calculate that, not the whole circle. So here we go. The area formula for a sector of a circle is A equals pi r squared times the degree of the central angle divided by 360. The radius is, in this case, 5. So pi times 5 squared times the degree, which is 40, over 360. All right, now we're going to calculate this in terms of pi, which means we are not going to use pi in the calculator. So we're going to go to Desmos, and we're going to type in just the 5 squared times 40 divided by 360. And we're going to hit the fraction bar, and it's going to say it's 25 over 9. So all of these numbers here reduced to 25 over 9. And we got to bring this pi down. So that's going to give you that as your answer. Question number 2 is a circle within a circle. I'm going to redraw this here. Okay, so this question gives you the radius of the small circle, which is 4, and the radius of the large circle, which is 9. And it wants to know the area of the shaded region. All right, I have this redrawn out. What we'll do is we'll find the area of the small circle first. Actually, we'll find the area of the whole thing. And we'll pretend like this area here is shaded here that I'm putting in brown. So we'll do pi times 9 squared times 110 degrees over 360. Now, that'll give you the brown shaded area. This region right in here has a radius of 4, that little circle. So we're going to subtract pi times 4 squared times 110 over 360. Same degree, different radius. So we're going to do pi times 9 squared times 110 over 360, and we're going to do pi times 4 squared times 110 over 360, and we're going to subtract those two numbers. This one you want to actually type pi in because you have to round it. So that's going to give you about 77.75. The other one's going to give you about 15.36. Subtract those two from each other. And that's going to give us around 62.3955. And we're going to round that to 62.4. Question 3. The diameter of a circle below is 8 inches. What is the area of the shaded sector? All right, so the diameter is 8 inches. That means the radius is going to be 4. The degree, when we plug it into pi times r squared times degree over 360, will not be 230, as a lot of people mistakenly guess. It's actually going to be 360 degrees minus 230, because the shaded area is over on this side. So the whole thing is 360. 360 minus 230 is 130. So that's the degree that you want to use for that. So that's what you're going to plug into the calculator, round to the nearest hundredth. So pi times 4 squared times 130 over 360. So pi times 4 squared times 130 divided by 360 is about 18.15. Okay, question 4, moving on. The circumference of a circle is 30 pi. The length we want to find, but the central angle is 105 degrees. What is the length? All right, length of an arc is not the same as area of a sector. Length is circumference, 2 pi r times degree divided by 360. Circumference is equal to 2 pi r. So we don't have to solve for r. We just have to plug 30 pi in for 2 pi r. The degree is 105. And plug that into the calculator and you'll have your answer. You know, a lot of you probably aren't listening to this, so rubber baby buggy bumpers. Anyway, if you caught that, I hope that caught you off guard. Also, I'm really hungry right now, so if you have any food suggestions, that would be awesome. All right, 30 pi times 105 divided by 360 is about 27.488. I'm gonna round that to 27.49. Yeah, that's good enough. It's just funny, you know, that I could give you all the answers and some of you still won't do the work. It's sad, actually. But anyway, that's where we are in this society. All right, 27.49. All right, question number 5. Moving on. A central angle of 86 degrees intercepts an arc with length of 10.3 inches. What is the diameter of the circle? All right, same formula. 2 pi r times degree over 360 degrees. Doesn't it get boring after a while, just doing the same thing? Gosh, it's like I'm making you practice. All right, central angle is 86. Arc has a length of 10.3, wants to know the diameter. So the length is 10.3. The degree is 86, and it wants to know the diameter. So we actually have to solve for the radius so we can double it for the diameter. So your length is 10.3, that's gonna go there for L. We don't know R, so we'll say 2 pi r times 86 over 360. That's a lot. So my suggestion is leave the r alone. In fact, what I would do is just calculate 2 pi times 86 over 360. and just leave the R, move that over here for now. Put this stuff in your calculator. 2 pi times 86 divided by 360. Let's see what that is. I'm guessing it's going to be small. 2 pi times 86 divided by 360. 1.5, nice. So 10.3 equals 1.5 R. Isn't that beautiful? Now it's just a number that equals a number times a number. Got rid of the pi, got rid of the fraction, divide. Cross your fingers, hope you get it right. All right, what is 10.3 divided by 1.5? 6.86666666666. 6.87. Oh, but that's not your answer, right? Because it wants to know the diameter. That's the radius. I almost put 6.87 in the answer. See, I can mess up too. I'm a human being. You might not think that. All right, 6.87. The diameter is 2 multiplied by 6.87. So if I do 6.87 times 2, it should be about 13 point something. 13.74. So the answer to this question is 13.74. One more question. And if I get a 100 on this, I'm going to treat myself to dinner because I'm really hungry and I know it's only 4 o'clock. You don't know what time I'm recording this, but I'm hungry. That's the point. All right, so question number 6. Find the length of arc ABC if the radius of the circle below is 7 centimeters. Round to the nearest hundredth of a centimeter. All right, I'm going to redraw this circle again. This is a gotcha question. I didn't create it. I don't take credit for it, but I put it up every semester. So here's how you do it. Oh, ABC, that's the important part. I really don't like gotcha questions, actually. I only do this because it's on the test, to be honest. All right, so I want to know the length of arc ABC. Now you want to look at the order that these letters are in. A, B, C. So you want to start with A, and you want to go to B next. So if you go this way, you're going to C next, right? So you don't want that. So you want to go this way. And that would be like arc AB, which happens to be 1/2 of the circle. So guess what? That's 180 degrees right there. But it doesn't stop there, it goes to C. So that's actually the majority of the circle. You don't want to just use 70 degrees because that's only this portion, right? That's arc BC. So arc ABC is these two added together. 180 plus 70, what's that equal to? 180 plus 70 is, what's 18 plus 7, 25? Should be 250. You can double check my math, but I think I'm right on that. All right, so that's 250 for that arc. So that's the degree we want to use. So it also gives you the radius. So we're going to do 2 pi times 7 times 250 divided by 360. All right, we're almost done. Let's put it in the calculator. It's 413 somewhere. All right, 2 pi parentheses 7 times 250 divided by 360. 30.54321, 0, -1, -2. 30.54. All right, 30.54, round to the nearest hundred, 30.54, 30.54. Side quiz. Okay, how I get this right. Check that out. I got a 100 out of 100. And you can too, thanks to me. Have a great day. Bye.